Rationalizing the denominator. Like I said before, when you are working with radicals, you cannot have a square root on the bottom for your denominator. If you finalize your answer and you're still stuck with a square root in the denominator, then you've done something wrong. Or you've got a problem in which you have to rationalize, okay, meaning that you have to get rid of that radical in the denominator. So let me show you an example. We have square root of 5 over 12. Is 12 a perfect square? No. Can we simplify 5 over 12? No. So no matter what you do, you're going to wind up having a radical in the bottom because of the fact that 12 is not a perfect square. So there's two different ways that you could actually work a problem like this out. Because we do know that 12 happens to be divisible by a perfect square, then we could factor the 12 out and then work from there. But really that's just extra work. The easiest thing to do is to go ahead and rationalize right from the beginning. So when I mean rationalize, I mean take the square root that your denominator is and multiply both your numerator and denominator by that value. So if I multiply the numerator by the square root of 12 and I multiply the denominator by the square root of 12, this means I now have the square root of 5 times 12 over the square root of 12 times 12. So if you multiply a square root by itself, it just gets rid of the square root and you're left with a base. And this is the reason why. 12 times 12 is what? 144. And what's the square root of 144? 12. So when you multiply a square root by itself, you're just getting rid of the square root and you're keeping the radicand that's inside. That's your answer. Okay, now in this case, we get square root of 60 over 12. Can we simplify the square root of 60? Can we break that up? Is there a perfect square that can go into it? Demi? Huh? Not 16. What perfect square can go into 60? A 4. 4 times what? 15. So we can break this up into the square root of 4 and the square root of 15. All of this is still over 12. What's the square root of 4? 2. So we now have 2 and then the square root of 15. Again, all of this over 12. Now, I'm going to go ahead and put the 12 right on underneath the 2 because they're both outside of my radical. So I want to focus on it as if this was my fraction, 2 over 12. Can we simplify 2 over 12? 1 over 6, right? These are both divisible by 2. So I'm just going to be left with 1 square root of 15 over 6. Or you could just write it as square root of 15 over 6. That's the more common way that it's going to be written. They won't put the 1 in front. And that's it. That's rationalizing the denominator. It's not that hard yet. Sometimes people think it's a little more difficult once you add in variables. I don't think it's that big of a deal. Here, try this one on your own. The square root of 7 over 2. All right, what did you guys get? Jimmy? Very good. Square root of 14 over 2. So all you're going to do here, again, 7 over 2 cannot be simplified, so you just break it apart. This is basically square root of 7 over the square root of 2. You're just going to multiply both the numerator and the denominator by the square root of 2. Okay, so this becomes the square root of 7 times 2 over the square root of 2 times square root of 2, which is what? 2. You know, you get square root of 4, yeah, but that simplifies to a 2. I mean, here, we'll even write it out if we need to, so that way you guys can actually see it. This becomes square root of 14. This becomes the square root of 4. Square root of 4 can be simplified, right? It is a perfect square, so therefore it's going to come out to a 2. But the square root of 14, we can't factor it. The only factors are 2 and 7, and 1 and 14. And none of those are perfect, so it stays square root of 14. And there's your final answer. Okay, let's try one more. Let's try a little something different. You haven't seen this before. 2 square roots of 80 over the square root of 7. 2 square roots of 80 over the square root of 7. So I've always given you guys problems in which you have only had square roots and you haven't had anything that has been simplified outside of it yet. But this is no different. Having that 2 on the outside is no different. Okay? So pretend it doesn't exist for the time being, and this was just the problem. What would we have to do first? Brent? Multiply by square root of 7. Multiply top and bottom by the square root of 7. Now that square root of 7, are we multiplying that to the 2 or to the 80? To the 80. You're multiplying a square root to another square root. So you're multiplying 80 and 7 together. That 2, again, is its own separate thing. So I'm going to put that in a different color. I'm going to go ahead and put that in blue. So that way I know it's different. And then I'm going to do 80 times 7. What's 80 times 7? 560. Okay, and then square root of 7 times square root of 7 is the square root of 49. Now, I can break up the square root of 560. What perfect square can go into 560? Well, I'll help you out with that one because we don't have time. Well, 14 is not a perfect square. 16 is a perfect square. So you have the square root of 16 that you can break it up into. And then you also have the square root of 35. 16 times 35 is going to go ahead and give you 560. And then, of course, underneath it, you still have your square root of 49. Now, square root of 16 and the square root of 49 are both perfect squares. So, again, we still have that 2. But now we've got the square root of 16, which is what? 4. What do you think we're going to do then? Not add. Multiply. This means that you're multiplying 2 times the square root of 80. So that means whatever comes outside of that square root of 80 gets multiplied with that 2. So it becomes 2 times 4. And then you still have that square root of 35 over, what's the square root of 49? 7. All right, what's 2 times 4? 8. So you now have 8 square root of 35 over 7. Can we simplify 8 or 7? No. There's nothing you can divide into 8 that you could also divide into 7 to simplify it, except for a 1, and that wouldn't simplify it. So there's your final answer. 8 square roots of 35 over 7. All right, now it doesn't matter whether it's just numbers or if you have variables, it's still the same exact process. If you have variables, you still have to make sure that you simplify it and don't have a radical variable in the denominator. So if you happen to be left with a square root of x in your denominator, then you would multiply both the numerator and the denominator by square root of x. Okay? It's the same exact process whether you have a variable or not. So let's take a look at the problem. Okay, square root of 50 is not perfect. Square root of x is not perfect. So I'm going to go ahead and just multiply both the numerator and the denominator by the square root of 50x. If I do 13 times 50, that's going to give me 650. And then I still have my x. Now, if I do 50 times 50, that's going to give me 2,500. And x times x is going to give me x to the what power? To the second power, so I have x squared. Now, again, here we're looking at this being a perfect square. So this would just simplify to 50x. And then the square root of 650, we can go ahead and break that up. Who can tell me what factors? Anybody? Well, look here. What would be a perfect square that goes into 50? 25. So that same exact perfect square is going to go into 650. If 25 can go into 50 and you're just multiplying 50 with another number, 25 will go into that other number too. 25 and 26. 25 and 26. So square root of 25, and then the square root of 26. Now, where do you think the x is going to go? Is it going to stay with the perfect square or the non-perfect square? Non-perfect, because x is not perfect. So we're going to leave it here with the 26. Okay, and what is the square root of 25? 5. So we now have 5 square root of 26x over 50x. Okay, look at my pink. Can I simplify anything there? What are they both divisible by? 5. So I can divide this by 5, and I can divide this by 5. 5 divided by 5 is just going to give me a 1. Do I have to write the 1? No. So I can just write square root of 26x. And what's 50 divided by 5? 10. So we're going to get 10x mixed in my square root sign. And that's my final answer. Try this one on your own. Bless you. Raise your hand if you have an answer. Ashton? So close. So close. There's one little thing that you're missing from it. So it should be square root of 6x over 3x. Square root of 6x over 3x. So let's go over that. Okay, there are two different ways. I'm going to actually show you one way, the way that you probably are all doing, and then I'm going to show you another way that you could do this so that you're not working with such large numbers. But if you're multiplying both by 48x, or the square root of 48x, you're going to be working with some really, really, really large values here. Okay, 32 times the 48 is going to give you 1536. So you'd have square root of 1536 and then the x. And then the square root of 48 times the square root of 48, square root of 48x times the square root of 48x, that's going to give you 2,304 and then x to the second power. Now again, this is a perfect square, and then the square root of 1,536 can actually be broken up into the square root of 256 and then the square root of 6x. That x is still remaining there. Your denominator would be simplified to 48x. Now, square root of 256 is what? Come on, guys, it's a perfect square. What is it? 16. So you get 16, and then you get the square root of 6x over 48x. Can I simplify 16 and 48? What are they both divisible by? Well, they're both divisible by 16. Okay, so that's going to leave me with 6x inside of a square root, so square root of 6x, over, and then 48 divided by 16 is going to leave me with a 3, so we get 3x, and that's your final answer. Now, like I said before, you can actually work with this because we already know 48 is not a perfect square. Already know that. And there's nothing we can simplify 48 by that would turn it into a perfect square. So just simplify the whole thing then. So that way you're dealing with smaller numbers. So write that problem down again. Both 32 and 48 are divisible by what? What's the largest factor they're both divisible by? 16. They're both divisible by 16. So just do that ahead of time so that you're working with much smaller numbers. 32 divided by 16 would give you square root of 2. 48 divided by 16 would give you the square root of 3x. And then you're dealing with smaller factors. A lot easier to deal with. Same process, multiply both by the square root of 3x. And that's going to give you the square root of 6x over the square root of 9x to the second. 9x to the second happens to be a perfect square. And lo and behold, you didn't have to do any more simplifying. Square root of 6x is on the top, and underneath you get 3x, and you're done. A lot easier, right? Yeah. All right, so that was page 13. On page 14 is where your homework is going to go. And I'm nice today. I printed it for you. Great, you'll do a lot of writing on top of it. So on page 14 is where your homework is going to go. That's what the homework is going to look like. And that's page 14.